Hi, and welcome to an incredibly beautiful geometry puzzle that I personally almost despaired over, even though a similar problem once appeared in a middle school competition. So it can't actually be that difficult. The goal is to calculate the side length of this square here, and all we know is that we have 6 units of length here, 2 here, and 8 here, and that, as you can see in the sketch, there are also 2 right angles built in. Go ahead and pause the video and see if you can find the super elegant solution to the puzzle, or maybe just a more complicated one that also gets you to the answer. In a moment, I'll give you a few tips, show you what I struggled with, and how I eventually did find the elegant solution. Tip number 1, but I have to say, this one leads to a dead end. I thought, right angle, somehow I must be able to get somewhere with the Pythagorean theorem. And then, pretty foolishly, I spent the whole time trying to find right-angled triangles and drew in all sorts of auxiliary lines. Something like this, and I thought this here would be a right-angled triangle. Maybe I could do something with that. And then also here, that didn't really lead anywhere, so I started looking for parallelograms, something like this, and I really tried a whole lot of things. And at some point I just got fed up and thought, okay, Magda, today is not your day, somehow you're just too dumb for this puzzle right now. And I almost wanted to give up on the whole thing. And speaking of dumb, here's a little fun fact. Ever wonder where a word like dumb comes from and what it means? And in contrast, what about a word like splendid and where it comes from? Think about it. It's pretty funny. In any case, in the end, I wasn't too dumb for this splendid puzzle. Instead, I found the solution. And the trick was that, much like with the congruence puzzles, I just drew in everything that somehow popped into my head. Everything that came to mind, and to do that, I first extended these lines here, like so and like so. And then I thought I can also make this whole thing a bit symmetrical, so I started again here in the bottom corner and just played around a bit, and I came up with the idea of having it intersect at a 90-degree angle. Here, from the top left corner, I did the same thing again. And then I saw, in a truly real and huge aha moment, hey, this entire thing looks remarkably similar to the pinwheel from the puzzle we worked on just a few weeks ago. I have right angles everywhere here, in every single corner, and I know that because of this, the whole thing is therefore a square. And because of the symmetry, if this side length is 2, then this side length here must also be 2. And since I knew this part was given as 8, it was clear that if I put the side length of 2 into the small square, I can basically forget about the 8. Instead, I'd rather just draw in this part here, which is then 6 units long, and I can do that all the way around. So, in the square, I always have the side lengths 2, 2, 2, 2, and then I have 6 here and 6 here, and similarly 6 here and 6 here. And then I just generously erased what I no longer needed. I got rid of this, got rid of that, and this and that. And lo and behold, now you probably recognize, if you've seen the video, the little pinwheel. And this little pinwheel, that was the trick of it, was made of 4 right-angled triangles, all congruent, meaning they're identical, just like this one here. We have 4 of them. And because these 4 congruent triangles are right-angled, I can very easily, and indeed super easily, calculate the area by simply treating this 8-unit long side as the base and the 6-unit long side as the height. And as you can see, I've calculated the area of the entire square quite easily. In fact, it was a straightforward process. I said, well, according to my sketch, the whole purple square is now perfectly made up of 4 times this red triangle, each with a base of 8 and a height of 6, plus this funny little thing in the middle. But that's just a square with a side length of 2, so we add 2 times 2 for the area. So in total, I get 4 times 1/2 times base times height, plus the 4 square units from the square. And that makes 4 times 1/2 is 2, so 2 times 8 times 6 plus 4. And if you calculate that, 2 times 8 times 6 is 96. That means I get 96 plus 4, and that is 100. This means if my square has an area of 100 square units, then I know if I just call the side length x, that x times x equals 100, and from that it immediately follows that x must be 10. And with that, ta-da, without any major use of the Pythagorean theorem or anything like that, we've easily figured out that the side length of the square is 10 units. And I think I never would have found this solution without the pinwheel problem. You can find that one here. You see, practice makes perfect. Take a look at the puzzle playlist to see if you've missed anything else. You'll find it up here. Have fun with it and see you soon. Ciao.